So let's start walking through this first proof that we're going to do today. We have a picture here with three labeled angles, angle 1, angle 2, and angle 3. We have our given, and we have what we are trying to prove. So what should go in this top box right here? Yep, the given information. Angle 1 and angle 3 are supplementary. Please put your phone away. Angle 1 and angle 3 are supplementary. Why am I allowed to say that? Because it's the given. All right, there's another reason that we can fill in pretty easily. What other reason can we fill in right away? Yes, the measure of angle 2 equals the measure of angle 3. There's lots of things that we'll say in between, but I want to get the thing that I'm trying to prove down in that bottom box. The measure of angle 2 is equal to the measure of angle 3. Yep. Now, we do not know why we can make that statement yet. We're going to have to fill in the other reasons. Specifically, I'm going to need to know what's in statement 5 that would let me move to this point that I can make statement 6. All right, let's go back to where we're starting. Angle 1 and angle 3 are supplementary. Angle 1 and angle 3 are supplementary. Well, 1 and 3 aren't touching at all, are they? No. But angle 1 and angle 2 are touching. And I want to say something about angle 2 down here at the bottom. So I've got to say something about angle 2 at some point in my proof, or else I'm not going to be able to get to that spot that I'm trying to get to where it says angle 2 is congruent to angle 3. Sorry, measure of angle 2 is equal to the measure of angle 3. Well, first I have to introduce it. First I have to start talking about it here. So angle 1 and angle 2. What do you notice about those two angles? They're a linear pair. Yes, so that's the next thing I'm going to write down is angle 1 and angle 2 are a linear pair. Angle 1 and angle 2 are a linear pair. Why would I be allowed to say that? I can't just write over here because the picture shows me so. So we got to find a reason off the red paper that I would be allowed to say that angle 1 and angle 2 are a linear pair. Definition of linear pair. Or rather, definition of a linear pair. All right. If two angles form a linear pair, what do they add up to? 180, because they are what? What do we call angles that add up to 180? Supplementary. So I can't jump from saying they're a linear pair to saying they add to 180, but I can say they're supplementary. If you look on your red paper, I want you to find something else about linear pairs. Find another reason that uses linear pairs. So there should be something else about linear pairs on there other than definition of a linear pair. What'd you say? The linear pair theorem. What does the linear pair theorem tell us, or how can we use it in the proof? Correct. If two angles form a linear pair, here in step 2 we established that these two angles form a linear pair. then I can say they are supplementary. It doesn't say, then I can say they add to 180. It says, then I can say they are supplementary. So linear pair theorem would be my reason for being able to make this statement. Linear pair theorem. All right, now we can make our next leap though, because if I know they're supplementary, you guys already told me this, but I'm going to ask again. If I know they're supplementary, then I know they add up to what? 180. So I can say the measure of angle 1 plus the measure of angle 2 equals 180. Give myself a little bit more room because I want to write two equations on this line. Measure of angle 1 plus the measure of angle 2 equals 180. Didn't we know about another pair of angles that added to 180 in this proof? Angle 1 and angle 3, because right here we were told that angle 1 and angle 3 are also supplementary. So that means they would also add to 180. Measure of angle 1 plus the measure of angle 3 equals 180. In statement 1 and statement 3, we said those angles were supplementary. Why am I allowed to say that means they add to 180? My 9-year-old wouldn't know that. So we're using something that we learned in this class. Definition of supplementary angles, yes. Definition of supplementary angles. I don't have enough room to write the whole word angles, so I'm using the angle symbol. All right. So I have angle 1 plus angle 2 equals 180. And I have angle 1 plus angle 3 equals 180. Well, doesn't that mean that angle 1 plus angle 2 equals the same thing that angle 1 plus angle 3 equals? So I can write that down. I can write the measure of angle 1 plus the measure of angle 2 equals the measure of angle 1 plus the measure of angle 3. They both equal to 180, so I can set them equal to each other. There's two different reasons that I could use here on this one. We could say, well, I took the 180 out from this equation and I replaced it with all of this. If I make a replacement like that, what's happening? Substitution. The other thing that I could say is I have something equal to 180 and something else equal to the same 180. So these two things have to be the same size, and that would be my transitive property. So we can use substitution or we can use transitive property here. Either one works. Substitution or transitive property. All right, we are at our last statement that we want to make. We already know what the statement is, we just need a reason for it. What's different between statement 5 and statement 6? Yeah, we have measure of angle 1 on the left right here, and the measure of angle 2. Angle 2 stayed, but angle 1 went away. And over on the right, we also have the measure of angle 1 that down here disappeared. Yes, subtraction property of equality. You guys are fantastic. Subtraction property of equality. That was beautiful. Absolutely beautiful. All right. Let's look at number 2. Try to work our way through that proof. Number 2, I've got this X shape with 4 labeled angles, angle 1, angle 2, angle 3, and angle 4. Then I have my given and what I'm trying to prove. What are the pieces that I can plug in really fast? Yep. We're going to say angle 1 is congruent to angle 2. So statement number 1 is angle 1 is congruent to angle 2. Why can I say that? Because it's given. There's one other statement that I can easily make. What is the other statement that I can easily make without thinking? I need you to put your phone away, please. Please make sure your phone stays put away. Angle 3 is congruent to angle 4. And where are we going to put that? In step 5, statement 5. Angle 3 is congruent to angle 4. Don't know why I can say that yet. I won't know until I get here to step 4 and I see what's different. All right. So I'm starting with angles 1 and 2 and it says they're congruent. And somehow I'm supposed to get to angles 3 and 4. Well, I know angle 1 and angle 2 are congruent because they told me so. Normally, I can't make that assumption, right? They're side by side. What do we call those side by side angles? Linear pair, that's right. There's another special angle pair that we've talked about. Linear pairs and, starts with a V. Vertical angles. What do we know about vertical angles? They're congruent. That's really helpful. Notice I'm saying stuff about congruent here. So angle 1, what would be the vertical angle for angle 1? Angle 3. So I know angle 1 and angle 3 are congruent. Angle 1 is congruent to angle 3. Is there a vertical angle for angle 2? Which one? 4. So and angle 2 is congruent to angle 4. Why am I allowed to say that? What did we know about angles 1 and 3, angles 2 and 4? They're vertical angles. So why am I allowed to say they're congruent? Vertical angle theorem. Vertical angle theorem. Beautiful. All right. Might seem a little strange, but we're going to go for it. At the end down here, which side do I want angle 3 on? I want it on the left. When I look right here, which is the first time I've introduced angle 3, right? It's the first time in my proof we saw angle 3. Which side of the congruent symbol is angle 3 on? Here it's on the right of this congruence. Down here I want it on the left. Up here it's on the right. So I have to find a way of getting it to the other side. So why don't I just take this whole congruence statement and flip it around? If angle 1 is congruent to angle 3, then would it be fair to say angle 3 is congruent to angle 1? What property lets me just take a whole thing and flip it around? Symmetric property. Symmetric property. All right. I want angle 3 to stay on the left-hand side. So I know in my next statement, angle 3 is going to be on the left with a congruence. I don't want angle 1 here. What do I want? I want angle 4. Are angle 1 and angle 4 the same size? Are we told that anywhere up above? No. But angle 1 is also the same size as what? Angle 2 and angle 3, but I already have angle 3 written down, so I'm not gonna change this to a 3 because then I would just have something congruent to itself, which is true, but it doesn't help me get to 4. But I can say angle 1 and angle 2 are the same size. So I can replace angle 1 with angle 2. Now, normally when I make a replacement like this, we use what property? Most of the time we use substitution, but I can only use substitution if there's an equal sign. I don't have an equal sign here, so I need something that works like substitution. Transitive property, yes. Transitive property. All right. So what's different between statement 4 and statement 5? Yes, 2 and 4 are congruent. We know that from right here. So we can use that to make this swap. I would love for it to be substitution. That's exactly right. It's still the transitive property. We're going to use transitive property a second time because I don't have equal signs, so I can't use substitution. So it is transitive property. Fantastic. You guys are rocking this. Absolutely wonderful. All right. Let's flip the page and look at proof number 3. Proof number 3. Got a picture. We have our given and what we're trying to prove. My given information right here goes as my first statement. So angle ABE and angle DBC are right angles. I'm allowed to say that because it is my given. And then we have the thing that we are trying to prove, which goes in my last statement box. In this case, it would be statement number 6. The measure of angle ABD is equal to the measure of angle EBC. Don't know why I'm allowed to say that yet, but I know that's the last thing I want to say because that's what I've been asked to prove. Please keep in mind when you're doing these proofs, prove or proven is never a reason. You will never write down prove or proven. That's what you are doing. That's the process that you're going through. All right, all right, all right. Let's see what we got here. So angle ABE. Here's angle ABE. It said that's a right angle, which is marked on the picture, but I'm trying to make sure I can visualize these angles that they're talking about. So here's ABE. And then DBC is this one right here. So these two angles are overlapping, right? Do they have anything in common that they share? They're both right angles, yes. They share B. Where are they overlapping at? What is in the interior of both angles? E is? What else? D. So this whole angle right here, angle DBE, is in the overlapping space between these two angles. They share this angle. All right. The angles that I'm trying to talk about at the end are ABD and EBC. ABD is this little piece over here, and EBC is this little piece over here. So I'm going to have to try to talk about those. Let's go back to our given. Let's go back here. ABE and DBC are right angles. If they're right angles, how big are they? 90, yes. So the measure of angle ABE equals 90 degrees, and the measure of angle DBC is equal to 90 degrees. My 9-year-old hasn't studied right angles yet. She wouldn't understand the reason that we're allowed to say this. Here we were told they were right angles. Why does that mean I can say they're equal to 90? Yes. Definition of a right angle. Definition of a right angle. So if they're both equal to 90, are they the same size as each other? Yes. So I could say the measure of angle ABE is equal to the measure of angle DBC. The measure of angle ABE is equal to the measure of angle DBC. There's two different reasons I could use for this. What's one? Here I knew ABE was equal to 90. Here I knew DBC was equal to 90. And then in this step I said that means they're equal to each other. There's two possible reasons I could use here. What'd you say? They're not written as congruence. What reasons off the red paper could I use? There's two right answers here. There we go. We could use substitution to say this, because I could say, well, I'm going to take the 90 out from right here, and I'm going to replace it with DBC. That would be substitution. Or we can use the transitive property here. ABE is equal to 90. DBC is also equal to 90, so they have to be equal to each other. That's the transitive property. So substitution or transitive property. When you are doing your homework and you run into something like this, you're like, I think I can substitute. I also think I could use transitive property. You only have to write one of them down on the line. If this was a test question and you wrote substitution here and that's all you had as this reason, that would be correct. If transitive property was what you wrote down here and that's it, that would also be correct. You don't have to write both of them. You choose which one you're going to use. Okay, so now I finally have an equal sign with an angle on the left and an angle on the right. Just like I do with what I'm trying to prove. I have an equal sign, an angle on the left, and an angle on the right. So far, so good? Let's look at angle ABE, because I want it to be ABD. I don't want ABE. Let's come up here and look at angle ABE. That's this blue one. There's two small angles that got put together to make ABE. What are the two smaller angles that are being added together there? ABD and DBE. So I can say the measure of angle ABE is equal to the measure of angle ABD plus the measure of angle DBE. Can I make a similar statement about angle DBC? DBC is the one in red here. What are the two smaller angles that make up DBC? DBE And EBC, yes. The measure of angle DBC is equal to the measure of angle DBE plus the measure of angle EBC. These two statements that I wrote in the same box, because I'm going to use the same reason for both of them, that I got from the picture, right? I didn't get that from the stuff up above. I got that from the picture. Why am I allowed to say, look at your red paper, why am I allowed to say that two smaller angles put together give me a bigger angle? Addition postulate, what are we adding? Angles, two angles. So this is the angle addition postulate. You were absolutely right. Angle addition postulate. Angle addition postulate. All right, one more statement, two more reasons. I want ABD on the left. In step 3, I have ABE on the left. But what do I know that's the same size as ABE? What did we just write in statement 4 that's the same size as ABE? What is the same size as ABE that we wrote in step 4? Yes, these two right here, ABD plus DBE, absolutely. So I'm going to take ABD plus DBE, and it's going to replace ABE. So I have the measure of angle ABD plus, I'm going to need more room if I'm going to fit this all in, the measure of angle ABD plus the measure of angle DBE equals, on the right hand side of the equal sign, where I'm trying to get to has EBC. Do you see EBC anywhere else up here? Where? Second equation. Here's EBC. EBC plus DBE gives me DBC. Where else do you see DBC? The third one right here. And here, to be fair. But this is the one I'm looking at. I'm going to take everything after the equal sign, and it's going to replace this DBC. So all of this right here takes the place of DBC. So the measurement of angle DBE plus the measurement of angle EBC. All right, let's look at why we are allowed to say that. Substitution, I love it. Fantastic. Substitution property. This one I can't use transitive on, because transitive you always have to have three things. Here we could have used transitive property because I had ABE, that's one thing. We had 90 degrees, that's another thing. 90 degrees again, so that's still the second thing. And DBC, there's my third thing. When I look at what I did here, I have ABE, that's one thing. I have this sum, that's a second thing. I have DBC, that's a third thing. And then I have this sum, that's a fourth thing. So I can't use transitive property on this because I have 4 pieces instead of 3. Subtraction on my last step. What are we subtracting? Measure of angle DBE. We are taking away from both sides. This is the subtraction property of equality. Fantastic. fantastic work today. Absolutely fantastic work today. Your homework is due on Monday. Your homework is due on Monday. Tomorrow is the last lesson of this module. We're going to finish up your notes packet tomorrow. Then you'll have the weekend to get your homework assignment done. Monday, we will start reviewing for your test, and on Tuesday, we will continue to review for your test. Test is on Wednesday.